Now we're going to look at using the DC or define constant directive. Now when we use this directive, not only does it set aside memory locations, it actually puts something into the memory locations. Now on the right hand side we have a little bit of C code. Now it doesn't matter if you're not used to writing C code, the actual nomenclature of the language here is not important. So what we're going to do here is we're going to print "Hello, how are you doing?" to the screen. So we're going to generate a character array and we're going to put these values into it. We're going to work out the size of the array and save it in array1_length. We're then going to run through the for loop, which will work its way through each of the elements of the array and then print the character to the screen. And we will return here once it's printed out each of the characters, and it'll go around and it'll print out the next character and the next character. So this is a little for loop along with our array. And on the left hand side we have our code here written in our assembly language. So again we have our origin 0x8000, our start address is 0x8100. We can define the constant, so I call the constant array, we can define the array, so I'll call this array1, and it's defined using the define constant or the DC directive. So the array is going to contain "Hello, how are you doing?" And we have to work out the length of the array. So the array length here in the C program is worked out using this array length size of. Now we don't have this functionality built in yet because we don't have a high level language. All we're going to do here at the moment is just count the number of entries here, and the number of entries here is 25. So our array length is 25, and we know that if we're going to print it to the screen, because we're using memory mapped IO, the print character is going to start, the print character subroutine is going to start at 0x0160. Now if you are unsure of that, you can always go back to the video whenever we looked at getting the character from the keyboard and printing the character to the screen. So we're going to be using those subroutines which we generated in those videos. So what we're going to do here is, again, we're going to pass the two values in. Now again, we're just keeping it simple and we're just passing in by value. We could pass in using our stack, or we could pass in using our relative method. So we're going to pass in array1_length, and it's going to, first of all, it's going to be in register R1, and the beginning address of array1 is going to be in the index register, and we're going to pass these into our subroutine print character. Now the subroutine print character will then work its way through the array, and there's one of the commands within the print character subroutine which is an indexed command, and it will do the indexing, meaning it will go to the first address of the array and then it'll add on a value for the index register, so as it goes to the next address and then the next address and then the next address. So all of that is taken care of within the jump to subroutine, and that's the beauty of us writing subroutines that we have tested and we know that they work. It's taken out all of the coding that we would have required in order to print the character to the screen. Now whenever it's finished, it will return from the subroutine and it will return to the position just after the call to the subroutine. So it will jump to this position here, which is end, and it will just end the program. So here we can see a neat little bit of code that's only 4 lines long, and in fact if we take away the end it's only 3 lines long. So let's put this code into the CPU and we'll see it working. I have assembled the code and loaded it into the RAM. I've slowed down the simulation speed and we will go and simulate this now. So you can see here it's loading in the values for the ASCII text that we've generated in our define constant command. So that's it finished loading it in. Now you can see it then goes and grabs the values and it prints the values onto the screen, and you can see it printing out, "Hello, how are you doing?" Now it's not the fastest, but that doesn't matter. It does work, and you can head down in and you can watch the code actually being generated throughout the CPU. So this is a nice, neat little way of printing directly to the screen using the DC command and using an array and passing the values into the subroutine which prints the values onto the screen. So we've taken a few of the things that we've learned over the last few videos and we've added them all together into this one video, which allows us to print information directly onto the screen really quickly and really easily using our assembly language. Now that's enough for the assembly language, and we've learned enough of the basic structures that we can now go ahead and we can generate some quite complicated code, because we've got all of the basic structures that we will require from, say, for example, a high-level language. So in the next section, we will look at generating a small graphics library, and we will be able to use everything we've learned so far in the course in order to allow us to generate the assembly language which will allow us to create this library. That's all for this video. I'll get you on the next video. Goodbye.